So today we are going to start with the next chapter of yours, that is polynomials. We have finished with real numbers with certain problems, and as I told you earlier, we'll be going for some extra problems, and that subsequently will host in the YouTube channel. So you'll be in touch with that. And please subscribe so that you get the notifications as immediately as possible once I upload any new videos. So let's start with polynomials. First, let us try to know what exactly is polynomial, right? I'm going to give you the formal definition here. It is any expression of the form fx equal to an x to the power n minus 1 x to the power n minus 1. Here it may be plus or it may be minus. These type of expressions are said to be polynomial. Remember that these an minus 1, etc. are all real numbers. The first, that is the coefficient of x to the power n, these are also coefficients. This particular is known as leading coefficient, and it should be non-zero. This is very definite, because if it becomes 0, then this term will not exist, the highest power term, right? And n is a whole number, and this type of expression is called a polynomial, and this n is known as a degree. Degree means it is the highest power involved in the polynomial, right? Highest power of the variable involved in the polynomial. So we'll start some example. Small example, let me start with, say twice x square plus 3x plus 2. What is the degree of the polynomial? It is a polynomial, this is sure. Degree is 2, right? The polynomial, this polynomial have degree 2. Number 2, suppose that I have written x to the power 100 plus 2x to the power 99 and then 1. Will it be a polynomial? Yes, it is a polynomial with missing powers. That is not an issue, because this missing powers means how can you allow them? Like here the coefficient is 1, x to the power 100, that means value of this a is 100. Next it is 2, x to the power 99, then there is no other terms, right? So I can write like this, x to the power 98 and 0 into x to the power 97, and then so on, and I can go up to 0 into x, and then this is what. So you have these values, right? These coefficients, some of them are 0 and the others are 1, 2, etc. So this is a polynomial. Have I explained very quickly? If so, please replay the slide and then try to see that. The next, there is a very small question now. Even if I am writing it as 3, so just try to answer. Is this a polynomial? So this is cube, 3x plus 2. Is this a polynomial? Yes, this is also a polynomial. But remember, here I did not write them in the standard form. Standard form means not in the decreasing order of the power of the variable. So it is a polynomial. Only thing is that degree is not 2, degree is 3, because the highest power is here. So sometimes somebody might trick with you by giving this kind of expressions. Now next, will this be a polynomial? Absolutely not. Here you have to be very careful, because this, you see, this is root over x. Root over x means x to the power half, and here what we mentioned, n is a whole number. So n is a whole number. I have to reduce n in such a way that it reaches here minimum 1, and if nothing is mentioned here, it means we are having x to the power 0. So the last number we allow for variable is 0. Otherwise all are whole numbers. So here this is not a whole number. So this is not a polynomial. This is what you have to take care of, right? Anyway, this already you got in class 9, so you will not find more problem of it. Okay, so let's move on to the next slide. Some name we assigned on the basis of the degree, so that also you should know, so that we can afterwards refer to it. A polynomial whose degree is 0 is called a constant polynomial. So all numbers 3, 4, 5, maybe half, etc. can be considered as constant polynomial. But there is an exception. We do not call 0 as a constant polynomial. So please mention it is excluded. This is called 0 polynomial, and for 0 polynomial degree is not defined. That's a very important note to be marked, right? All other numbers we can use, all other real numbers we can use as constant polynomial. Then polynomial with degree 1 is called linear polynomial. So a linear polynomial will be having degree 1. So its general form will be ax plus b. If somebody tells you that consider a linear polynomial, so your form is this. Example, I can take say twice x plus 3. Okay. Then quadratic is ax square plus bx plus c. Right. Examples already I have taken. Cubic uses raise a higher power, then it is a cube plus bx square plus cx plus d. But always you try to mention, do not forget to mention, once you write the standard form, very clearly you should always write that the leading coefficient is not 0. Otherwise it will not be any more a polynomial of this kind. Biquadratic means power is 4 and then degree 5, a polynomial of degree 5 only you have to say. We do not have any specific name after this, right? So if anybody who is saying that power is 6, so it is a polynomial of degree 6, like that. Okay, what I was talking about this only as an important note, the 0 of a polynomial, the 0 polynomial has no degree. That means the degree of a polynomial, 0 polynomial is not defined. Very, very important, right? Many times this comes as a multiple choice question and students commit mistakes. They write 0 polynomial has a degree 0, which is very wrong. Come to the next. 0 of a polynomial. Okay, what does the word 0 of a polynomial mean? Let us discuss first with the definition, then I'll give you examples. Let fx be any polynomial. Actually, in the first slide only you have seen that we have named the polynomial by writing this fx. So it's not that only fx, we may write gx, we may write hx, right? We may write px, we may write gx, we may write say dx. Many such letter we can use for writing the polynomial. So for example, we have considered fx to be a polynomial. Then the value of x, say alpha, some value of x, say alpha, is said to be a 0 of this polynomial if f alpha is 0. Means if you replace x by alpha and then you find the value of the polynomial and then it becomes 0, then what we say, this particular alpha is said to be a 0 of the polynomial. Then the value of the polynomial at x equal to alpha is 0, that is this, it's incomplete. Then x equal to alpha is called a 0 of the polynomial, right? 0 of the polynomial. So that is to be understood. I'm taking example. Say I have fx equal to x square plus x minus 2, a polynomial I have. Now I ask you to put x equal to 0. Then what will I get? You all know how to do it. X equal to 0, if you put here, it means f of 0 I get. That means 0 square plus 0 minus 2, giving a minus 2. Is this 0? No, it is not 0. Then say 1 I put, f of 1 I put. It is 1 square, 1 minus 2. Is it 0? Yes, that's the important part for us. This is 0, right? That means when I put x equal to 1, then I got f of 1 equal to 0. So here what will imply, x equal to 1 is a 0 of the polynomial. Am I clear to you? But here you see, if I put 0 also, the value doesn't come out to be 0. So this is implying that x equal to 0 is not a 0 of the polynomial. Have you understood what I am trying to mention? 0 of the polynomial means those values which, if you replace in the polynomial, ultimately gives a value 0. In this case, 0 itself may not be a 0 of the polynomial. So this is little confusing. So you take little time and then review this, right? Okay. So you take little time and then you take examples. You can take many other examples. Now there is a general question which is coming to my mind. Suppose I have put x equal to 1, then I got 0. Now, will there be any other values if I put for x in this polynomial? Again, I'll get a 0. Okay. Anyway, test. Let's test a few of them. I ask you to test. Say x equal to 2, you test. What you get here? X equal to 2. It will be 2 square plus 2 minus 2 give you 4, not 0. That means this will not be 0. What if I test x equal to minus 2? F of minus 2 will be minus 2 whole square minus 2 will be 0. That means I got x equal to minus 2 as another 0. There are two zeros you got so far, right? So you got this also as 0, this one and this one. Now again, suppose that I ask you to continue putting this value, say now 3 minus 3, right? Say half minus half. Now do you expect that some more values will give it 0? So that is an important question, right? You will not get any other such values for this, and that will be decided by the degree of the polynomial. Am I clear to you? So whatever is the degree, that many maximum zeros you can get. Maximum zeros, not more than that. Maximum real zeros, right? So we'll be discussing it in detail. Let's move on to the next slide. Okay. Graph of a polynomial. It's a very important part again. Graph of a polynomial. Consider the polynomial fx of degree n. Anyway, say one polynomial I have told you fx. कुछ expression होंगे यहाँ पे. Let it be there. Now I am asking you to draw the graph of it. Now do you know, to draw the graph of any curve you need a table like this, right? From coordinate geometry or linear equations class 9, we have come to know that we need x and y values, then only we can get the points which we will plot, and then we can get the graph, right? But here though everything is in x, how will you get y? For that we will name this fx itself as y, and then we will construct the points. For example, let me try to take, for your simplicity, right, for your explanation, a very easy equation, so that I will not take much time in explanation. Say x plus 2 is a polynomial, linear polynomial. So I have to create the points. Now you see y is this one only. So if I put x equal to 0, what is y? 2. If I put x equal to 1, what is y? 3. That means the value of fx is nothing but y. Then minus 1, if I put it is 1. Likewise you can complete that. And then the rest of the graph you know already. Should I draw a graph? Anyway, as I have started with this, I will show you the graph. So now 0, 2. Roughly I am putting 0, 2 is a point here, suppose. Up to here 1 I have considered. This is 1 point. So 1, 3. 1 is here and 3 will be here, suppose. And then minus 1 and then 1. 1 will be here. So now if you join them, this will be a straight line, right? So this will be a straight line. So likewise you can do. Okay. So now right at this moment I'd like to tell you something about the structure of the graphs of the different polynomials which we get at least up to cubic or biquadratic. See, constant polynomial, right? Constant polynomial means whose degree is 0 will be always parallel to x-axis. That it is always parallel to x-axis. Suppose y equal to 2, so it will be having a distance for y equal to 2 always, no matter what x you consider. So your graph, sorry, this is not correct. This will be parallel to x-axis like this. Say y equal to -2, then it will come like this. Next, if it is a linear polynomial will be always a straight line intersecting, right? Linear polynomial always will be a straight line intersecting x-axis at one point like this. That means it will be either like this or like this. Then your next is quadratic polynomial. If you have a quadratic polynomial and you draw the graph, it will be always looking like this or looking like this. These are known as parabola, right? You'll get to know it in class 11. And then if you go for cubic will be always like this or always like this curve. They may intersect x-axis at one point or maybe at 3 points. And then if you get biquadratic, so they may be like this or they may be like this. Okay, so up to here if you know, it will be okay. Their curves are of this shape, so it is better to know till here. Now next, geometrical representation of 0 of a polynomial. Graphically what we'll get, right? So they have mentioned graphically the point where the graph of a polynomial intersect or touch the x-axis represents the 0 of the polynomial. Why? See, I'll go back to the previous slide. Now you see, did you get any value of x here which you put here becomes 0? No. If I put x equal to -2, what do you get? 0. Right? That means f of -2 will be 0 for this. What do you say as this x equal to -2 as? It is a 0 of the polynomial. It is the only 0, right? It is a linear polynomial, so only one 0 will get. So we have got a 0 by putting such a value of x which gives you y equal to 0. Fine. Now while drawing the graph, while putting the points, where will this point lie? Because y is 0, where will it lie? It will lie on the x-axis, because at all points on x-axis y will be 0. So always you try to remember, whenever y coordinate is 0, the point will lie on y-axis. Sorry, x-axis. That means the point where the graph will intersect x-axis, that points will have y coordinate 0, and in turn corresponding value of x is nothing but the 0. That's what has been explained here very nicely. So quickly we can get some say figure here. Supposing that somebody tells you that there is a polynomial like this, graph like this. So how many zeros? It is intersecting once, so 1 0, 2 0, 3 0, because at this point whatever may be the x, value of y will be 0. How many zeros will be there for this curve? 1. How many zeros will be for this curve? It is touching at 1. It is 1 0. That is true, but it is a repeated 0. Just try to see, because the curve structure is of quadratic. Quadratic has 2 zeros, right? So as 2 zeros are there, so that both the zeros are being represented by this. So here I would like to tell you a very important point. Please note that whenever a curve is touching the x-axis, there underlies two zeros, right? But distinct, one distinct, but there are two zeros which are both equal. Let's go to the questions, right? You will be finding these questions in a book also. Find the number of zeros of the polynomial from the following graph. So it's very clear. 1, this is 1, this is 2, and this is 3. The third zeros. So here how many zeros? 3 zeros. How many here? 1, 2, 3. Here also 3 zeros. You write 3 zeros, but these 3 zeros are distinct. If you are talking about distinct zeros, then there are 3 distinct zeros. But total, if I ask you, how many zeros? Here 2, here 1, here 1. Total 4 zeros. Out of that, 1 is repeated. So distinct will be 3 zeros. Now reverse question can be asked. What is the degree of the polynomial corresponding to this graph? It will be 3 here, because all the 3 zeros are distinct. What will be the degree here? Now you see, if you write 3 zeros, answer is correct, but degree will be 4. Why? Because there are 2 zeros for this. So degree for this polynomial will be how much? 4, whereas degree of the polynomial for this will be 3. Okay. Similarly, if somebody gives you the unit, I did not give you the unit here, you can find the zeros also. Say this one, say 10 means 1 unit, I consider 1, 2, 3, 4, and then this is 4.5, right? So this 0 will be 4 half. Sorry, not 4 half. Ah, yes, 4 half. 4 half is x equal to 4 half, that is 9 by 2 is 1 of the 0. Like this. This also can be read. Now here, how many zeros? How many zeros? Only one point it is intersecting. So it is 1 zeros, right? 1 zeros. What is the degree of the polynomial? Is it 1? Is it linear polynomial? C. This will not be a linear polynomial. It is a cubic polynomial. A cubic. Degree will be 3. How did you come to know that degree is 3? See the structure. Right? Degree 1, that is linear polynomial, will be always a straight line. But here it is not a straight line. It is a curve like this. This is a pattern of cubic curve. This is how many points they are intersecting? 1 point. So degree is 1 and it is more of a straight line. So degree of the polynomial will be 1, 0 will be also 1. But many times students commit a mistake telling this also as one of the 0, which is wrong. 0 is always to be taken from x-axis, not from y-axis. Very, very important point. Mind it. Next. What about this? What about this? Students might count 1, 2, 3, 4, 5, 6 around. They have to count only this. At how many points they are cutting? Intersecting x-axis 1. So it is 1, 0. And what is the degree? No need to discuss about that. This is a complicated curve. Then next, this is what? How many zeros? It is no zeros. No zeros. Actually, no zeros is not very, very clear concept. We should write no real zeros, because it is not intersecting x-axis anywhere. So we do not get any 0 here. So does it mean that it doesn't have any degree? No, it has. It is what type of curve? Can you identify? It is quadratic parabolic curve. So parabolic curve is always representing a quadratic polynomial. So today this much only we will discuss. Okay, we will be discussing further more, little more, and then in the next period we will extend our discussion. So for this time, start with the polynomial. Till here what I explained will be enough for you to finish the first exercise and do it please. Okay, thank you so much.